Welcome, everyone. My name's Graham Hunt, and I'm the co-convener of this Sydney Central branch of Renew. And on behalf of all the branch committee, I welcome you all to our webinar. Firstly, I want to acknowledge the traditional owners of the land upon which the Sydney Central branch operates from and where I am at the moment, which is the land of the Gadigal clan of the Eora Nation. We acknowledge and pay our respects to the past, present and future traditional custodians and elders of the whole nation. And we also acknowledge their sustainable stewardship of the country over many millennia. Please feel free to let us know where you're joining us from by dropping your details into the chat box. For those of you who are new to Renew, just a few words about us. Since 1980, Renew has been inspiring, guiding, and helping people to become more sustainable. We have branches and members all over Australia. We invite you to become a member if you want to know more about renewable energy, how to make your home more sustainable, or if you're looking at renovating or building a new home, then Renew could be for you. Perhaps you're a professional working in the housing industry and want to know how to find out more practical solutions. Renew is a source of extensive knowledge. It's also a great interactive community of like-minded people who thrive on sharing their experience. It has leading magazines such as Sanctuary and Renew and runs Sustainable House Day each year. There are various options for membership. To become a member or find out more, go to the link which is we dropped into the chat now. I would also like to make an announcement about our next webinar, which is still in planning, but is likely to occur during the first week of June. It will be held in conjunction with the Renew Sydney Western branch and will be on the topic of cooling Western Sydney and the urban heat island effect. We are hoping to have Dr. Sebastian Faust, the Associate Professor from the Uni of Western Sydney, who is doing some exciting research in this area. So keep an eye out for emails about that. So now to tonight's topic. We have been waiting for over 12 years for an increase in the stringency of residential energy efficiency provisions of the National Construction Code, or more commonly called the Building Code. Over that time period, the ravages of climate change have become much more apparent and are right at our door. The inadequacy of our housing in face of these challenges has been made apparent. Improving the energy efficiency and thermal performance of houses can assist in making housing much more resilient, but more importantly, can contribute significantly to reducing emissions, which is essential if we are to survive climate change. Back in 2018, what was then just called Climateworks prepared with ASBEC, which is the Australian Sustainable Built Environment Council, a report called The Bottom Line, which looked at the household impacts of delaying improved energy requirements within the building code. This report became the starting point and foundation for what was to become the trajectory for low energy homes that resulted in the current proposed energy efficiency changes for the building codes. Therefore, it is only appropriate that tonight we have as our speaker Michael Lee, Research and Analysis Manager from Climateworks Centre, who will further explore the importance of better energy performing homes in the context of this accelerated climate action and future uncertainty in regards to energy costs. If you have any technical issues during the evening, please use the chat function on the side of the screen to get assistance. If you want to ask questions, please use the Q&A button and not the chat box. We will go through some questions at the end of the presentation. It is normal that we get more questions than we'll have time for, so please be patient. We will also be recording the presentation, and that should be available on Renew's YouTube channel in about a week or so. Once it has been updated, an email with the link will be sent to all participants. So now I take the pleasure of handing over to Michael. Thank you.
Thanks, Graham, for that introduction, and welcome and thank you everyone for joining this webinar this evening. It's a great pleasure to be invited by Renew to present to you all and to be able to talk to you a little bit about the work that we've been doing and some of the progress that's been made in the National Construction Code that Graham talked about. Just going to pop up my slides on the screen now. So as Graham mentioned, I'm the Research and Analysis Manager at Climateworks Centre. And before we launch into the presentation, I do want to acknowledge and pay respect to the traditional owners and elders, past, present and emerging, of the lands and the waters of the people in the Kulin Nation on which our office in Australia is located. And in particular, I'm speaking to you from the Wurundjeri people right now. And I also acknowledge that sovereignty was never ceded and it was and always will be Aboriginal land. For those of you who aren't familiar with Climateworks, we are an independent non-profit organisation that drives climate action across Australia, Southeast Asia, and the Pacific regions. We're an independent organisation that was co-founded by the Monash Sustainable Development Institute and the Maya Foundation, and we work within the Monash Sustainable Development Institute at the university. And so over the next half hour or so, what I'll cover today is really a discussion that's focused around the proposed changes to the National Construction Code for 2022. So that will be announced and coming into effect this year. And so we'll start off with, I guess, a bit of a discussion on why energy efficiency is important for buildings, a bit of an introduction to what the National Construction Code actually is and what the changes are being proposed for this year. And what's some of the research that we and Renew actually and others have shown about the impacts and the benefits of introducing these changes to the National Construction Code for homeowners, and also what the impact is if these changes aren't adopted. And finally, I'm going to conclude on a discussion around the future aim for a zero emissions building code. It's important to note that we will be covering the benefits and impacts from a householder perspective, because that's really what our research is focused on. And the research that I'll be presenting by Climateworks, and that Graham mentioned, was completed in partnership with ASBEC, the Australian Sustainable Built Environment Council, and supported by their industry members. So it's a piece of research that has pretty widespread support in its development and in its presentation application moving forwards. So first of all, why are we even talking about buildings and why are we talking about decarbonisation? I'm sure it's not news to many of you on this call that buildings do make a major contribution to both emissions and electricity consumption. So what our research shows is that buildings make up around about a fifth to a quarter of Australia's national emissions. And in Australia, the building stock that we have here, particularly residential buildings, is pretty notorious for, especially when you kind of look at the media around housing energy performance, for having some of the poorest quality energy performance in the developed world, especially when it comes to housing. Some examples of this include a study that Sustainability Victoria did a few years back now actually, that showed that the average energy performance for houses that were built before 2005, so before energy standards were introduced, was around about 1.8 stars out of the maximum 10 stars that's available in the NATA's rating scheme. And just for comparison, the current minimum standard for new construction, for new housing, is 6 stars. So there's a pretty big gap between what existed before the code, which is 1.8 stars, and what's being built today at that 6-star level. And even though this survey had some limitations about being based on a small selection and where the properties were located in Victoria, it does actually show that there is, based on this sample, a gap between existing homes and new homes being built in Victoria and where I'm based, but also across Australia. When we look globally, the International Energy Agency did some analysis on energy efficiency for housing and found that during the period between 2000 and 2016, Australia was ranked 5th worst in the improvement in energy efficiency for housing out of the 28 countries that were reviewed in that study. And on top of all that, again, as Graham mentioned, the energy standards for housing in the National Construction Code in Australia haven't been strengthened in over a decade. So not only are we falling behind our international peers, and not only are we starting from a pretty poor quality building stock, regulation isn't been changing and hasn't changed for a long time to be able to actually allow Australian housing to catch up. What our research shows, and other people's research shows as well, is that many of the technologies and the practices that are required to reduce carbon emissions in buildings already exist and are readily available today. It's commonly, I guess, acknowledged that there are 3 very broad main ways to reduce carbon emissions from buildings. First of all is to improve energy efficiency, to actually reduce the energy that's being used in the first place. The second is to switch any non-electrical power sources and power demand to electricity from particularly gas. And then finally is to produce and to store energy on site at the property. And this can be achieved by a whole range of existing technologies and practices. Some of those are listed on the right-hand side of that slide there, and many of which I'm sure this audience is pretty familiar with. But even though our research shows that these technologies and these practices are available, the main challenge is how do we actually achieve widespread deployment of these practices over a very short period of time? Now, I'm sure you've heard in the news recently, but also over the last 6 months, that there's great urgency for the global community to reduce emissions in line with keeping global warming below 1.5 degrees above industrial levels. And back in 2020, Climateworks released a report called Decarbonisation Futures, which calculated the changes in Australia's economy that need to happen by 2030 to keep climate change in line with that 1.5 degree target. And so what that shows, what our research showed is that under the 1.5 degree aligned scenario that we modeled, rooftop solar power generation doubled by 2030 compared to today's levels. But it's important to note that the decarbonisation of the building stock isn't just about solar panels. Even in our scenarios where the electricity grid is powered by up to 79% renewable energy by 2030, so that's a pretty ambitious increase in renewable energy in the electricity grid, the energy performance or the energy efficiency of housing would still need to improve by almost 50% compared by 2030 compared to today. And in commercial buildings, that would need to improve by around about 28%. Not only does the energy performance need to improve on top of the renewable energy expansion, but our scenarios also included a fairly significant amount of electrification. So by 2030, in our scenarios, about 3/4 of all energy demand is met by electricity rather than gas and other sources, compared to around about 50%, just under 50% today. And so what does that look like when you kind of break it down into different parts of our building stock? Well, if we focus on housing in particular, for new housing, our scenario that aligns with that 1.5 degree target includes an improvement in energy performance for new housing of between 51 and 56% compared to housing that's being built today. So what that suggests is that housing would need to be built significantly above today's minimum standards. And then also for existing buildings, an improvement in energy performance of 41 to 44% compared to today's standards. So what that compared to the building stock that we have today. And so what that suggests is that not only do we need to be building more efficient new buildings, but we also need to rapidly accelerate the rate at which we retrofit our existing housing for better energy efficiency. And so really what that shows us is, so what we know is Australia has targeted net zero emissions by 2050. That was a target that was announced late last year. But that target can't be achieved without a focus on both retrofitting existing buildings and a continued commitment to deliver more efficient new builds. And so this presentation will very much focus on the new builds, and in particular, a regulatory policy, a regulation called the National Construction Code. So the new buildings and the performance of new buildings is really important for decarbonisation of housing and the building stock, because new construction does add up fast. We estimated that by 2050, about half of Australia's buildings that will be standing at that point haven't actually been built yet. And so even though every year the proportion of new builds is quite small compared to the total building stock, that does add up over time. The good news is that there is a ready-made regulatory mechanism for new buildings that governs the energy efficiency, performance, and minimum regulatory requirements for all new housing, which is the National Construction Code. And back in 2009, the Council for Australian Government, the Council of Australian Government's Energy Council, which is essentially a group of all the energy ministers around Australia at the state, territory, and national level, agreed to a policy that they called the Trajectory for Low Energy Buildings, which they termed as a national plan that sets a trajectory towards zero energy and carbon ready buildings for Australia. And what that plan recommended was, first of all, setting a trajectory, a pathway towards zero energy and carbon ready buildings. Secondly, to implement cost-effective increases to the energy efficiency requirements in the National Construction Code starting from 2022, so this year, noting that the policy was approved and published in 2019. And finally, to continue to focus on existing buildings, as I flagged before. And I guess the wording that's in that policy is an agreement to substantially update the minimum requirements in the National Construction Code from 2022, where it's cost effective. One of the reasons why the National Construction Code is so important is not just because it already exists, that's very helpful, but also because minimum standards and stronger minimum standards and the existence of minimum regulatory standards allows everyone to enjoy the benefits of better energy performing buildings. There's estimates that groups like the CSIRO have done that show that only around 5% of residential buildings are currently being designed significantly above minimum standards for energy efficiency. What that shows is that even though there is still, it's not an insignificant chunk of the market that's building above minimum standards, 5% isn't nothing, but that does mean that 95% of the market for new housing every year is missing out on the benefits of high energy performance, which I'll go through a little bit later, based on the research that Climateworks, Renew and others have done. And so if those energy efficiency requirements in the National Construction Code are strengthened, then those benefits are shared amongst all new houses and new apartments that are being built and the people who are going to be living in those homes, not just those who choose to build above those minimum standards. Now, for those of you who either have been following over time or have heard about the National Construction Code, you'll probably know that it is quite a tedious and dry process that we go through when it comes to these sorts of regulations. I've been working on this for years, and I can tell you from firsthand experience that it is a very dry process. So forgive me if you start getting a little bit confused when I talk about how the code is actually implemented, but it's important to understand, I guess, the process by which that happens to really understand where the points of influence are and I guess rationale for why we've done the work the way we have. So the way that it's implemented is that there's a body called a national body called the Australian Building Codes Board, which is responsible for drafting the changes to the code, consulting on those changes to the National Construction Code, and conducting any sort of analysis or modeling, like what's called a regulatory impact statement, which is a cost benefit analysis of any proposed changes. And what that body does, which is a national government body, that Australian Building Codes Board drafts and writes those changes into a national construction code, which is a document that they essentially pass on to the state and territory building and planning ministers. And the reason why they do that is because the laws around building construction and new construction are actually implemented at the state and territory level. So it's not a national set of regulations, it's a set of regulations that is unique to each state and territory. And so what that means is that any changes to the National Construction Code need to be both approved and then implemented and signed into law by the relevant state and territory building and planning ministers when they're updating and reviewing the legislation of building requirements, just general building requirements, including energy efficiency requirements within their own jurisdiction. And so there's this whole kind of national and state and territory dynamic and process that the National Construction Code goes through to actually implement any of these changes that we've been doing the research on. And the reason why we're presenting on this now is because these changes are currently being reviewed and currently being considered by governments. Over the past 6 months or so, this has been whole regulatory analysis process, and this has been a culmination of years of work by the Australian Building Codes Board and advisors and researchers in industry groups and organisations like Climateworks and Renew. And where we are at now is that the new version, the proposed new version of the National Construction Code is currently under review. It's a bit of a closed door process. So since the consultation that occurred over the second half of last year, even Climateworks, we haven't actually really had visibility over what the specific changes are. Later in this year, so starting from May and then going across the next couple of months following that, the state, territory, building and planning ministers will then make a decision on what changes they will approve, what changes they will actually implement, and how they might stick with the national consistent standard for the National Construction Code, or where they might potentially vary for their own jurisdiction. So it's a bit of a, I guess, it's watch this space status in the moment on what's going to happen with the National Construction Code. And so some of the changes that are being proposed relating to energy efficiency of housing in the code include, there's three main changes that I'll go through. There's lots, actually, there's lots more, but I'll talk through the three most high level ones. First of all, raising the thermal performance requirements from 6 stars to 7 stars under the NATA scheme. And that NATA scheme refers to the building fabric, so things like insulation, windows, shading, orientation, all that sort of stuff. So the building fabric and the energy efficiency, so the energy requirements for heating and cooling, that requirement will upgrade from 6 to 7 stars under that scheme. Secondly, the Australian Building Codes Board is proposing to introduce what is commonly called an energy budget, which is essentially a budget for the maximum allowable energy that a home can use over the course of a year. And this energy budget covers heating, cooling, lighting, and hot water, and there is an option for renewable energy as well. And finally, includes, the third change here is that it will include it's proposed to include a requirement for apartments and commercial buildings to have the electrical infrastructure, the wiring, the distribution boards available and installed with enough capacity to allow for the future retrofitting of renewable energy systems and also electric vehicle charging. So importantly, the code isn't proposed to actually mandate electric vehicle chargers, for example, but for apartments and for commercial buildings, if this proposal goes through, it will require the electrical equipment in those buildings to have enough capacity to allow for the significantly higher electrical demand that's going to come from the electric vehicle charging. Now, for those of you who are still following, just to confuse and muddy the waters a little bit more, the Australian Building Codes Board has actually proposed 2 different options for how these 3 high-level changes are going to be implemented. And again, because we haven't had visibility over those changes over the past 6 months or so, we don't know which option the code is likely to go down. But just so you get an idea about the level of ambition that's being talked about here, there's 2 options, option A and option B. Option A is essentially, for want of a better word, a less ambitious option when it comes to strengthened energy improvement. It allows for a high energy budget, where essentially actually is it allows for more energy to be used over the course of the year, which is a lower energy performance. And also option A doesn't allow for any on-site renewables to help make up or meet that budget. Whereas option B is an option that requires higher energy performance than option A because it has a lower energy budget. And it actually provides a slightly more flexible approach to meeting that tighter energy budget because it allows for an option to install on-site renewables to, I guess, help meet that budget. There is still going to be the minimum requirement for energy efficiency. So renewable energy wouldn't be a trade-off against a minimum baseline energy efficiency requirement. But it does allow for, I guess, flexibility to meet that tight energy budget, either through on-site renewables or potentially through better energy efficiency or electrification as well. So it does give that option for builders and designers to use their judgment for what's actually going to work for the site and for that building. Now, onto what the research says about the benefits of these changes and why we, as Climateworks and so many other organisations, are supporting these changes. You might have already heard as well that the ABCB, the Australian Buildings Codes Board, did some economic analysis on the proposed changes that I just outlined. And they actually found that when considered at the societal level, so not at the household level, but what does it mean for the whole of Australian society and the whole of the economy, their analysis actually showed that the costs of strengthening the code would outweigh the benefits. So they actually found that at a societal level, the changes would not be cost beneficial. And there's a whole range of reasons. I guess Climateworks' position and others' position is that there's a whole bunch of reasons why the assumptions that are made in the economic analysis skew it towards an unfavorable outcome, which are not consistent with the research that we and many other organizations have done. But if we put aside the societal result for a moment, that analysis that the ABCB published did actually show that when considered at the household level, the benefits do actually outweigh the cost. So it actually is cost effective. So for the vast majority of the cases that were modelled through this report that's on the slide and commissioned by the ABCB, the change from 6 to 7 stars for that thermal energy performance, the heating and cooling energy performance, is actually cost effective for the vast majority of the cases modelled. But even if they're not technically cost effective from a cost benefit analysis, the report still actually makes the case for higher stringency, higher strong energy performance in all climates for a variety of reasons, which include things like the impact on household cash flow over time, the longevity of buildings, the fact that emissions are going to be locked in, and all the benefits to do with comfort, resilience, lower stress on the electricity grids. There's a whole range of reasons beyond just the benefit cost analysis that why you would want to introduce those standards. But importantly, what it shows is that at the household level, for the vast majority of cases, the benefits outweigh the costs. This is the ABCB's commissioned analysis. And this is backed up by our independent research, so the research that we undertook back in 2018. So this is before these policies that I mentioned were actually announced, which showed that cost-effective changes to the National Construction Code can save hundreds of dollars a year in energy bills, adding up to $29 billion in residential and non-residential energy bills between now and 2050. And even when considered at the societal level, our analysis actually did show that the benefits outweigh the costs. And some of those benefits include reduced stress on the electricity grid, which means that investment in the electricity networks can be deferred or delayed, or maybe they're not needed over time, adding up to about $13 billion over the next 30 years. Plus, of course, reduced greenhouse gas emissions, which is the reason why Climateworks was interested in this work in the first place, improved health and comfort. And importantly, we did actually look at the cost of delay. So if these changes aren't actually implemented, that you can actually lock in a fairly large chunk of emissions that otherwise wouldn't have taken place and have to be offset or abated somewhere else in the economy where it actually might not be as cost effective. So I was just talking about the next slide, I just realized. So we can't actually, what our research showed as well back in 2018 was that we can't afford to delay these changes to the code. Our analysis estimated that a bit over 1 million homes will be built between 2022 and 2025. And over that 3-year period, if the National Construction Code isn't updated in 2022, if it's delayed to 2025 instead, then that can lock in billions of dollars in household energy bills that otherwise don't need to be incurred, and 9 million tonnes of emissions between now and 2030 that, as I mentioned, could have been cost effectively reduced through this change in the code, but instead have to be abated either through retrofitting existing building stock or in other parts of the economy, like in transport or in heavy industry, where it's less cost effective to do so. Finally, I'm gonna step ahead, thinking beyond the changes to the code this year, which, as I mentioned before, are currently in train. They're currently being reviewed, and the decisions are currently being made by the relevant decision makers in government. And to note that the reason why, one of the other reasons why we do support the proposed changes to the code this year is that making this change, which will represent the first change in household energy requirements in the code for over a decade. I think it would be something like 12 or 13 years since the last time that will have been changed. That change actually lays the groundwork for a zero emissions building code in the future. So that research, our research that we did in that Built to Perform report that I mentioned before back in 2018, showed that even higher energy efficiency than what's being proposed for the 2022 code can be achieved with net benefits to households and net benefits to society. And so on this basis, I guess our position is that governments should adopt the changes that are being proposed and that are almost being finalized for the 2022 code with minimal delay as well. With a plan to set the building code up for changes to the code that are aligned with net zero emissions, a zero emissions building code or zero carbon ready building code in 2025. And that's all to do with, I guess, the urgency of climate action, the fact that, this is, the changes to the National Construction Code are a cost-effective changes to a ready-made regulatory instrument. Nothing needs to be invented in this way. And so as a bare minimum, aligning the building code, the National Construction Code, with net zero emissions outcomes is needed as soon as possible. And in this case, we're saying by 2025 at the latest. So just to summarize, I guess some of the key takeaways that I've talked through. As we've seen, the building standards that we have here and the energy performance of our housing are lagging behind and international peers. And stronger energy performance standards mean low energy bills, improved health and comfort for all new housing, not just those who choose to build above current regulatory standards. The solutions to decarbonise buildings are ready, they're cost effective, and not implementing those solutions now and not implementing this change to the code now means that we'll have to invest a lot more in things like energy efficiency, the electricity grid, and other emissions reduction measures that might and are probably not going to be as cost effective. And just flagging again that while the step from 6 to 7 stars being proposed for the 2022 National Construction Code isn't at the same level as what our independent research has found to be cost effective. Adopting that will hopefully set us up for a zero carbon aligned building code in 2025. So as I conclude, I'll just note that you feel free to reach out to Climateworks for any questions. Even though I've been involved in this work for years, I'm actually not in the same role anymore. So just flagging that you're more than welcome to reach out to my colleagues, Margot and Jill. Jill's on the call right now as well, with any questions about our work. And if you want to have any discussions about our work, then feel free to reach out to Margot and Jill, and to myself, of course, obviously. And finally, I'll hand back to Graham to conclude and to spruik some of the resources that both Renew and Climateworks have put up and have made available for this audience. Thanks, Graham.
Yes, thank you, Michael, and thanks for all your insights into this. So we have a few questions. we can start with, I guess. Janet is asking, can we lobby ministers to go for option B? I guess we certainly can. And as you mentioned, it's state building and energy ministers who are critical. But the other interesting thing is we have a federal election coming up, so it's an opportunity to make it an issue during that campaign as well. I don't know if you want to add anything to that.
Yeah, so Graham, you covered it off really well. I'll just note that the relevant body who makes these sorts of decisions on the National Construction Code is a group called the Building Ministers Meeting. The Building Ministers Meeting is chaired, I believe, by Angus Taylor or potentially Jonathan Bunyam at the federal level, and includes all of the building or planning ministers at the state and territory level. So they're the body, the Building Ministers Meeting that makes these sorts of decisions on what goes into the code and what goes into their own regulations in their own jurisdiction.
I will let Janet know and the audience know that Renew has prepared a whole lot of resource material for people to use to approach politicians. And I think Marissa might be able to put a link to a page where those resources are available in the chat box. And if you also feel free to contact Renew, we're happy to assist you to do any lobbying in regard to this. So the next question, okay. Hudson is asking, is embodied carbon also part of the current proposed changes?
Yeah, great question. So no, embodied carbon isn't being considered at the moment in the National Construction Code proposal, and it wasn't part of the scope of our research either. The good thing is that it is being considered by another buildings-related national body, which is NABERS. So NABERS, which traditionally has done a lot of work in certifying energy performance of commercial office buildings. They're actually undertaking a project now to better measure and certify and independently verify the embodied carbon of building materials. NABERS, which what it stands for escapes me now, but it's NABERS. So they're the ones who are currently leading the national effort to actually, I guess, create a tool and create a standard for what how to measure embodied carbon and then reduce that in buildings.
It's worth noting that within New South Wales, and it comes back to that issue you're explaining where all the various states and territories, they're the ones who enact the actual legislation. They have a slightly different system called BASICS, and they've just announced proposed changes for that. And with the new changes, they will be starting to require a statement on embodied energy with building applications. So that it's good to see that coming in, but it's still not clear about the detail of that. Belinda is asking, could Michael explain the energy budget a little more?
Yeah, sure thing. So when a house consumes either electricity or gas in the main part over time, what you can do either in a model but also in real life through energy metering data is to actually add up and measure how much energy that house consumes, both electricity and gas, over the entire year. Some houses are going to consume more energy over an entire year. Some houses are going to consume less. And there's a lot of factors that affect that. As I'm sure many of you know, things like insulation and other energy efficiency measures, whether it has solar panels, the behavior of the house, the household, all that sort of stuff. So different households are going to consume different amounts of energy. In the National Construction Code, there are minimum requirements relating to particularly energy efficiency, insulation, glazing, that affect how much energy a house will consume over the course of the year. And so what the energy budget sets is that maximum allowable limit for when you put this house in some sort of calculation or a model, what's the maximum amount of energy that house is actually allowed to produce. If your model shows that the house is going to consume more energy over the year than the energy budget, then it means that as a designer or as a builder, you need to make decisions about how you're going to cut that down. through energy efficiency, or under that option B, you could also do it via, in part, by renewable energy as well. So it's basically a cap on how much energy a house is allowed to consume at that point of design, so during the design phase and according to computer simulations. Hope that makes sense.
Yeah. To me, I feel that having the energy budget is the more transformative aspect of these changes, rather than increasing the NATA's requirement, because as you explained, it sets the groundwork to then set up a net zero objective once you start having to, make choices about your energy options. Chris is asking, do you know if the decision will be made after the May election? I'm not sure. No. Do you know?
Well, that's definitely a crystal ball
Yeah.
question. So unfortunately, I wouldn't. In theory, because the Australian Building Codes Board, they're not a they're a regulatory body. In theory, the announcement should be separate to the election, because the ABCB has a specific regulatory, I guess, timetable that they're meant to follow. But as to the practicalities of, is that going to actually affect the announcement? Is the timing of the election going to affect that? Yeah, anyone's guess.
Yeah. Okay, Howard's asking, assuming the NCC 2022 code does require or does opt for the minimum 7 stars, what has to happen for the code to jump to 8 stars and to a zero emission target? Do we have to go through the whole same lengthy process again?
Yeah, it's a great question, because it's a bit of a yes, no, maybe type answer. Officially, these changes to the code are meant to go through the Australian Building Codes Board, the ABCB, through their formal process, which is a very lengthy process. However, the decision on what standards to adopt is actually a decision that's made by the individual government of the day, the individual building or planning minister. So it's one of those, I guess, situations where there's an official regulatory process, but there's also a political process in parallel, which could, in theory, make these changes happen a bit faster. So yeah, it's a bit of a, depending on which approach you want to take, you probably need a bit of both to make sure these things actually change.
Yeah, I agree. Traditionally, or certainly in the last few updates of the NCC, the Buildings Code Board has tended to do residential energy efficiency 1 update, and then commercial, and it appears that it's going to concentrate again on commercial for 2025. So if we are to get an update again for the residential, it will have to come through a political process, is my belief. Unless the Building Codes Board can be given much more resources so they can do the work. That's one of their problems, is just lack of capacity, I believe. Patrick has a question. Will Queensland still continue with the QDC MP41 sustainable building codes, which still allows 4-point star homes with bonus stars well below the rest of Australia? I don't know.
Yeah, I haven't heard any moves from Queensland to remove that variation from the national code. So if Queensland was to maintain their variation, which allows housing to meet a lower star rating if it includes an outdoor living area that meets minimum requirements, and then the outdoor living area has a ceiling fan. If that continues, then practically speaking, you'd probably be looking at, in that example, going from 4.5 to 5.5 stars. If that was to change in line with that national change. Having said that, again, don't really know what the plan is from a Queensland perspective, what those government decision makers are thinking. But if they weren't to change that variation, if they were to keep with that variation, that's probably what would happen.
Yep. So further on, in terms of embodied energy, Rob is wondering, would it be worthwhile to include standards on cement, concrete to further reduce the embodied carbon content? Well, certainly.
Yes, definitely. Yep.
Yeah. but yeah, it's not in the immediate agenda, but it should be. So Belinda's coming with a further question on the energy budget. Is the budget per square metre or by expected number of people or by geography?
Gosh, your audience is very interested in the technical questions, which is just testing my memory of this. So the budget will be from memory, it's a megajoules or kilowatt hours. It's an energy per square meter.
Yeah.
And it would vary. It would vary by geography, and it's based on the expected energy performance according to a 7-star NATAS rating, which in itself varies across different geographies. Plus, it assumes that a certain star level of heating and cooling equipment is installed, and a certain star rating of gas, hot water is installed, and lighting, certain watts per square meter of lighting as well. So those standards I just mentioned around the appliances, that doesn't vary by geography. That's just based on an assumption around what sort of appliances are put in. But the thermal energy performance, the NATAS bit, that's the bit that will vary by geography, and hence the energy budget would vary by geography.
I can add that it's a little bit more complex than that in terms of some of the actual calculations do take occupancy into account. Things such as hot water consumption, and but they're based on general assumptions based on data that's been collected over a long time. The next question from Hudson is, would the 7-star threshold be verified as built or only as designed? I guess I can answer that. The code does only set the design requirement. Again, because it's a state-run or state-implemented set of regulations, how that's verified as a state level is up to them to implement. It's certainly something that states are looking at in terms of increasing the compliance in that regard. But it's similar to what happens with any building compliance. It gets checked off by a certifier or some other authority. These from William. Does the standard specify the number of ventilation air changes per hour to control CO2 and all condensation levels?
So the proposal for 2022 will not include a minimum requirement on essentially infiltration or air changes per hour. So how leaky or how airtight the building is. Currently, there's an option that was actually introduced in. So currently, the way that the code is mandating their sort of air leakage requirements, which is something that's been put in place since 2019 in its current form, is that there's 2 options. The code loves options, as you can probably start picking up. The first option is to meet a bunch of what's called deemed to satisfy requirements, where you use particular, very specific mandated practices to improve and maintain the airtightness of particular parts of the house, like having a damper on ventilation fans, things like that. So it's actually quite specific about that. Alternatively, you can actually do an air tightness test, so a real life on-site air tightness test during construction or towards the end of construction, to show that the actual performance of the building meets a certain standard. And I can't quite recall what the figure is, but that's more of a, I guess, a flexible performance type requirement where you can actually show, yeah, I've actually done all the practices to make sure that the building and the air tightness of the windows and the house, the doors and the vents and everything meets a certain standard when you consider the house as a whole. So it's going to be, I guess, an option to verify using that air changes per hour type metric, but it's not actually mandated that you need to do that.
Okay. Greg is asking, what is the unit of measure of the energy budget? Is it kilowatt hours or CO2 equivalent? And how does the net zero goal fit in with this?
Yeah, so the energy budget is it's based on energy metrics, so it's kilowatt hours or megajoules, whatever the actual unit they choose. So it's not actually based on the carbon emissions of the building. That's consistent with the approach that Climateworks has taken in the past, and the rationale for that is that controlling the energy performance of a building is within, I guess, the scope of control of a builder or a designer of the building, because the actual emissions of that building is variable dependent on things like, well, primarily the grid intensity of, so the carbon intensity of the electricity grid. Because that's kind of outside the control of people who build and design buildings, there's, I guess, a bit less of a puts a bit less control and onus on being able to actually meet that through the National Construction Code. So, so it is an energy metric. Having said that, in terms of how it aligns with a net zero goal, that's where research by groups like Climateworks and others does analysis on, for example, what a whole of the Australian economy decarbonisation pathway looks like, particularly under a 1.5 degrees of warming scenario. And then as we do that modelling, we can provide an estimate of what different parts of the economy, different sectors need to do in order to contribute to that pathway. Our analysis shows that buildings is one of the sectors or the sector that needs to move the fastest. And we can actually pull out, there was that slide that I showed earlier that pulls out what the energy performance from a kilowatt hours per square meter basis looks like to actually align with that scenario that we modeled. So I guess in that sense, there's a bit of an indirect way that you can measure the fitness for purpose or measure the alignment of something like the National Construction Code with broader net zero goal.
Okay, we have one final question, which is from Belinda. Does the code apply to renovations or only new builds?
So it does apply to renovations where the scale of the renovation meets a certain threshold. What that threshold is varies across different states and territories, but it's usually based on a proportion of square meterage. So I can't remember the exact figures again, but it's something along the lines of if your renovation covers something like, I think it's over 40% or something, the building floor square meter, square meterage, then the code applies to that renovation.
Yeah. As you showed in your report, the need for upping the ante with retrofits and renovations of existing buildings is huge and not really being seriously addressed at this point. We have one question from Marissa, my co-convener, and she's asking if the proposed changes are taken up, how quickly do you think the price of expensive items such as double or triple glazed windows will go down? They certainly went down since when the update to 6 stars occurred 10 years ago. The range of windows and glazing options that are now available compared to 10, 15 years ago is huge, and the quality has improved significantly. So they're much more readily available. But I did hear, like in Western Australia, there's no, or in Perth, or south of Perth maybe, there's no local double glazing supplier. So it makes them very expensive. So in some areas it can be an issue. But hopefully, if as the industry becomes more accustomed to these changes, the whole building process should become more efficient. I don't know if you want to add anything, Michael.
No, you covered it really well, Graham. And yeah, we've tended to call that process market transformation, and the building code is a really powerful starting point for that market transformation because it sets that minimum expectation. And so even if not every single building takes up the best double or triple glazing, what it does is it lifts the minimum standard and it says that the expectation is higher than it was previously. And so therefore suppliers, for example, need to up the ante in what they're supplying in Australia or producing in Australia, and that we don't have evidence on how quickly the proposed prices would change, but the theory is based on anecdotal experience, like what Graham mentioned, that those sorts of changes will actually reduce those prices and help trigger that market transformation that Graham was talking about.
Okay. All right. Well, I'd just like to make one comment or question. You showed in one of your slides with your research that I think it was 55% was the amount we needed to improve the energy efficiency of houses if we're going to meet that 2030 target. Even if we get to net zero in 2025, we're still going to be short of the mark, I imagine, in that regard.
So if we go for a net zero code in 2025, then that will take us actually a fair way towards being able to improve that energy performance. But it's important to, I guess, note that it's not just about the net zero bit, the actual emissions bit, but it's also about the energy performance and the energy efficiency. And that's where the NATA's star rating becomes really important, because that's what governs the efficiency of heating and cooling a home, which contributes something like 2/3 of a home's energy consumption. Yeah. So in addition to having a net zero type requirement, strengthening that NATA's star rating, first of all to 7 stars this year, and then beyond, hopefully to 8 stars or maybe even beyond that, is a critical part of that as well.
So there is currently some resistance within industry to the changes, and even requests to, even if it's brought in, to have a transition stage to allow industry to adapt. I believe they've had plenty of time to adapt. They've known this has been coming for a while, but if they manage to negotiate like a 12-month transition stage, that's even aggravating that whole process further.
Yeah, and what our research shows is that any delay is going to be costly in terms of energy bills and emissions. And the urgency of taking action on climate change is real, and action needs to be taken today. And just the report, the international report by the IPCC, the collective of international climate scientists that was released earlier this year, had that exact same message: was that 1.5 degrees as a target for global warming is still achievable, but it requires that action essentially today.
Immediately. Yep. Okay. Well, I might bring things to a close there. So thanks very much, Michael. I think it's been a really good discussion. We've had some great questions, and hopefully we're getting some people engaged, and we need to try and get all these changes across the line. So Marissa has put into the chat the link to the Renew resources, so please feel free to access those. And again, thanks very much, Michael. And I'd also like to thank David Watton, who's doing all the technical work in the background and makes these events run so smoothly. And I'd also like to thank Marissa, who does the groundwork in organising these events and make sure they happen. So thank you to both of them. And at that point, I'll say good evening and thanks a lot for tuning in.